Okay, let's go ahead and finish up this lecture and get into something that's known as statistical power. And this is often a concept that students that take my classes have never really heard about before when it comes to statistics and what I'll call is traditional statistics, which is professor walks into the classroom, they put a bunch of formulas on the board, they walk you through how to calculate the formulas, and then you get a z-score or a t-score, and you compare it to the critical value that we talked about a couple lecture videos back. But remember, we have a series of basic assumptions. These are the conditions that need to be met in order for the test to show what it intends to show. So one of the questions that I really became intrigued with, especially when I was a graduate student, was understanding statistical power and sample size calculations. So really thinking about, how do I know how many people I need to recruit from the sample in order to accurately reflect what I should be seeing in the population? And so a lot of times people had really good ideas, but they weren't sure how many people they should be recruiting for their study in order to effectively determine that. This is where power analysis comes into play. It fills that gap and will tell us how many participants we need for a sample that we will eventually collect data on and run statistical analysis for to extrapolate them back to the larger population. So it's a very powerful technique, no pun intended, well, pun intended, that I think will be really helpful as you move through the course. So when you're preparing to conduct a research study, we want to know how powerful your statistical analysis is. So one of the other things to think about is, if you run a statistical analysis, how do you know you can trust it? The more powerful your statistical analysis is, the more you can trust it, which is a good thing. The sample size determination that we had just talked about is the second thing, determining the number of people you need to recruit and enroll and successfully complete your study in order to collect data, put it into an analysis, run it, and effectively extrapolate them back to the larger population. So from a definitional perspective, statistical power is the ability of a statistical procedure, and it could be any procedure we perform this term, to detect a true difference or to identify a true relationship. So when we run our statistical analyses with SPSS or JASP, we have to be able to be confident that the data we collected is actually what we should be seeing in the real world. And so the more power that something has, the more confidence we have in that analysis. How do you know the threshold for statistical power? Well, remember, when we covered type 1 versus type 2 error, we were referring to things like false positives or type 1 error. So the way you would calculate this in a power analysis is by taking 1 minus beta. And beta represents the likelihood of making a type 2 error. So if 1 represents 100%, and we expect type 2 error to only happen 20% of the time, which is a typical standard you'll see in statistical analyses, 1 minus 0.20 is going to give you a power threshold of about 80%. So that is the magic number. When we run a statistical analysis, we're looking for our power thresholds to be at least 80%, okay? So when we look at that 80% value, the number that we calculate from the power analysis is going to fall along the number line from 0 to 1. 0 is the floor, 1 would be the ceiling, and so 0.80, that 80% level that we had talked about, would fall within that range. And so that is the criteria to know if your data is statistically powered. Some of the other things that we do in the way we estimate power is you need to know what goes into the equation to determine the sample size or the power threshold. And so there are 4 key variables that you need to become familiar with when it comes to estimating the statistical power you have for your data set. The first thing is what's known as the effect size, which determines the degree or the magnitude to which an intervention worked better than a control group, independent of whether the p-value is statistically significant, by the way. The second thing is the sample size. The more, the better. The third thing is the significance or the alpha level, typically p less than 0.05. And the fourth thing is the statistical power, which we said is 1 minus beta, which is about 80%. So if you know 3 of these 4 variables, you can estimate and figure out what the missing fourth is. And we'll use a software program called G-Power in order to do that. The other thing that we think about when it comes to statistical power is identifying the relationship between power and sample size. And typically speaking, the higher your power, the greater your sample size. This is what we call a positive linear relationship. And the reason why it's that is because as one variable increases on the x-axis, the other variable is also increasing on the x-axis. And so you get a nice 45-degree line working its way through the graph here. That means as one variable goes up, another variable goes up. So the larger your sample size, the larger your statistical power most of the time. This last slide then will give us some general benchmarks that I think will be helpful as we perform different procedures throughout the term. So in general, there is a scientist, and his last name was Cohen, who came up with general universal effect size metrics. And he stated that an effect size is considered small when it's a value of 0.2 to 0. It's considered a medium effect size when it's at least 0.5 upwards of 0.8. And if it's 0.8 or larger, it's considered a large effect size. But as we will see when we perform things like t-tests and ANOVAs and bivariate and linear regressions, that there is different criteria for different effect sizes. And so we don't want to think about these means and these effect size metrics as small, medium, and large is always 0.2, 0.5, and 0.8. But when in doubt, it's a good first path through of how to check for that. So in this video, we talked a lot about different things. We started off by talking about hypothesis testing and understanding the difference between a null and an alternate hypothesis. We then talked a little bit about 1 versus 2-tailed t-tests, and then got into type 1 versus type 2 error. Once we got into type 1 and type 2 error, we then wrapped everything up with this power analysis discussion, and we will make sure that throughout the term you have plenty of practice so that these numbers become second nature to you and you know how to find them with every procedure we perform this term. So I hope this video was helpful. We'll see you all in class, and feel free to reach out to me and stay curious. We'll talk to you soon. Bye-bye.